Have you ever wondered how much heat is required to raise the temperature of a substance? To understand this, we delve into the realm of thermodynamics and explore the concept of specific heat capacity. Imagine placing a pot of water and a pot of oil on the stove, turning up the heat to the same level. You might notice that the water takes longer to boil than the oil. This difference is down to the specific heat capacities of water and oil. Specific heat capacity, symbolized as CE, is essentially the amount of heat that must be added to a unit mass of a substance to cause a 1-degree increase in temperature. It's like a substance's heat fingerprint, unique to each substance and varying with temperature and state of matter. Take water, for example, one of the substances with the highest specific heat capacities. To raise the temperature of 1 kilogram of water by 1 degree Kelvin, it requires 4,184 joules of energy. But ice, water in solid state just below 0 degrees Celsius, only needs 2,093 joules for the same temperature increase. Contrast this with iron, granite, and hydrogen gas. Their specific heat capacities are 449, 790, and 14,300 joules per kilogram per Kelvin respectively. Interestingly, during a phase transition like melting or boiling, a substance's specific heat capacity is undefined. The heat energy isn't raising the temperature, but is changing the state of the substance. Things get a bit more complicated when we consider gases. The specific heat capacity of a gas can vary significantly depending on whether it's allowed to expand, as it's heated or heated in a closed vessel that prevents expansion. These two values are denoted by C sub P and C sub V respectively, and their ratio is the heat capacity ratio. Now, specific heat capacity is also related to other measures of heat capacity. If we measure the amount of substance in moles, we get the molar heat capacity. If we measure it by volume, we get the volumetric heat capacity. So, to summarize, specific heat capacity is the heat required to raise the temperature of a unit mass of a substance by 1 degree. It varies with temperature, state of matter, and whether the substance can expand. It's a unique property of each substance and plays a crucial role in how substances absorb and release heat. It's the reason why a desert can be scorching hot during the day and freezing cold at night, or why water takes longer to boil than oil. Understanding specific heat capacity helps us make sense of the world around us and the energy interactions that constantly take place.